So we're going to move right into the next panel. Also, this is our last panel before lunch. And when you get lunch, don't forget to get a chance to go check out some of our exhibitors and maybe donate to the Lions Club flood fund, right? The ICBC is going to match up to 1,000 euros. So if everybody puts in 1,000 euros, we can drive Alex bankrupt. All right, which we shouldn't do because he flies me out here. Okay, coming up now to discuss harnessing research to move the industry forward, to lead this panel, to moderate. He's a researcher at the Research Institute and the Faculty of Health Sciences at the University of Ljubljana. Let's hear it for Roman Štukl.
Are we ready? Začnemo? So, welcome to the panel about research and industry, which I'm very excited to moderate, especially because if I remember correctly from previous ICBC meetings, which were held in Berlin and Barcelona, there was a conclusion made that cannabis industry is one of the last emerging and fast-growing industries of 21st century. And if we just quick look into the numbers, in 2021, the legal global cannabis market did more than 13 billion euros in revenue, and the legal global hemp market did almost 4 million euros. In European Union, the legal market is estimated to be worth up to 130 billion euros by 2028, and it's likely to become the world's largest market in next 5 years. So we see there is a lot of money involved in the cannabis industry, and we who work in the research field, we know that research is all about the money. And it is also known that there is no growth of any industry without a developed and financial stable research sector, which can produce next generation products. This brings me to my dear guest panelists. Here we have two from Slovenian research and academic sphere, Assistant Professor Andreja Čerenak from Slovenian Institute of Hop Research and Brewing, Luka Bitežnik from Biotechnical Faculty, and then we have two companies, Bence representing Genesis and Clement from Plan Z. And my name is Roman Štukl. I'll be a moderator of today's panel, and just a quick introduction, if we can start with the slides. So I'm a researcher at Research Institute in the Faculty of Health Sciences, where our main research activity is related to analytical identification and quantification of secondary metabolites in the cannabis plant. And for this purpose, we developed a methodology, and 1 year later signed still ongoing cooperation agreement with our industrial partner, Research Nature Institute. We have to say that our collaboration was very fruitful from the start, because we have opportunity to work with very internationally prominent people from research field of cannabis. Here on the picture you can see Dr. Hornby, who sadly passed away last year, but you can also see Professor Dr. Ilya Reznik and also Professor Hanuš. Our current activities related in the faculty are related to education. We also think that education is very important in the field. So together with our partner, we are organizing educational seminars in our faculty through the Center of Lifelong Learning. And in approximately 30 days, we will have already a third edition, and I would like to invite all of you knowledge-seeking people to come and join us on the event. We also have credit points for doctors and nurses. But our research activity is related to collaboration with the biotechnical faculty and also with Bence's company Genesis. In both cases, we are responsible for analytical support, but we also started to doing mapping of whole Slovenian mapping of products which were industrial and unindustrial. And last year we also had a privilege, or we were invited to show some preliminary results in Canna World Congress in Medellin, Colombia. Okay, so that will be from my side, but before I give the word to other panelists, I would like to ask one question, which I guess ask a lot, and I think many of you would like to know the answer to. I know, Andrea and Luca, that you are working and your organizations are the only one in Slovenia in the research field who, research in breeding, who also have license to grow THC strains for research purposes, which you will show in a minute. And we know that gene modification and genome editing presents fear among many of us due to the lack of the knowledge or any other reason. But for example, breeders around the world are already using gene editing to eliminate or nearly eliminate production of THC in the plants. But I would like to know from you if your research work on breeding also includes any gene modification technique.
Thank you for the question. We are in our breeding program are using different biotechnological methods and approaches, like different molecular markers, genotyping, tissue cultures, and so on. We are using also CRISPR in hop science, but not yet in cannabis. But we are looking forward for this now new EU regulation, which is focused on new genomic techniques, which will be approved, I hope, as soon as possible.
Great. And Luca?
Yes, thank you for the answer, for the question. So basically the answer is quite similar to Andreas. We don't use anything for genome editing, but we use some molecular techniques for support breeding. So yes, molecular markers for sex determination or genotyping. But as I know, there is a plan in our research group to use CRISPR-Cas on cannabis, but this would be just for research purposes, nothing for commercial
Okay,
use.
so the moment there is a GM-free plants growing, cool, it's always nice to know. Okay, so we will start with the panelist presentations, and after we go to the questions, first from me and then from the public. So please, Matea, Andrea.
So, hello. I'm coming from Slovenian Institute for Hop Research and Brewing. Since, let's say, the first relative to cannabis is hops, you can imagine that we can use our decades of experience and methods and labs and all other facilities for very useful breeding in cannabis industry as well. So I'm a plant breeder. I'm also professor at the University in Ljubljana for plant breeding. I'm the first author of more than 10 hop varieties, which are also plant protected, and we have American plant patent as well. So I think that we can really have successful breeding program in cannabis as well. My two topics, which I would like to expose, are the first is more linked to varieties which are growing outdoor. So we just realized years ago that in our varieties for outdoor growing are quite different between the population, since they are population varieties. And in 3 varieties, Carmagnola selected, Tirbo Salashi, and Finola selection, we found 11 different phenotypes. This is meaning that they can be morphologically different. So our idea was that we can find, let's say, a correlation between red vine and high CBD, perhaps in some variety, and then we can phenotype these plants, select them, and have a new variety, which could be used for outdoor growing. So based on that, we have done a different cannabinoid and terpene analysis. We were focused, as you can imagine, on the main types, components of both groups. And out of that we then sequenced also some spots in the DNA from different phenotypes, and we use different genome sequences which are now available, and we were focused on more than 40 different traits. We found, let's say, correlation with high correlations with perhaps THC synthesis, the gene which is mainly included in THC expression. So this is one of the PhD theses which is doing at our institute together with the faculty of biotechnical faculty and faculty of pharmacy, as Professor Strukel before mentioned, and show our first, let's say, scientific articles. The next one is We are very proud of that because this is completely a combination between private and public sector. So we have very good cooperation with Phytohemp. This is Czech company which is focused on getting different products from a cannabis plant, together with, as I mentioned, University for Pharmacy and Pharmet company from Ljubljana. So our main goal is to breed new cannabis varieties indoor. We have allowance, as Roman already mentioned. So our goals in our breeding program are, of course, high yield essential oils, compounds, high THC and high CBD. Our first goal is high THC, so we are working indoor. As you can see, we have now few generations. We are using molecular marker, as you can see, for sex determination, that we can be as much as possible efficient. We are doing our first crossings. We have very promising first results for high THC values. And now we try to also feminization, because we are trying to, of course, to have the variety which can be sold with, by using seeds or other clones. What is really painful for me, as my point of view, is that at the end, we need to destroy all this perfect material which could be really used for different kind of clinical research. And I think it was mentioned also before from the other panelists that our legislation needs to be, let's say, move forward in this kind of work as well. So we are using different feminization, as I mentioned, cuttings in vivo, then also in vitro techniques for different genotypes which we are using. And we are using our accredited laboratory for chemistry at our institute to determine all these mentioned compounds before. So thank you very much, and if there are any questions, don't hesitate to ask me later on. Thank you.
Thank you. Please, Luca, just follow.
Hello. Yes, I'm working on PhD thesis. I focus on cultivation of hemp and medical cannabis. And I'll present you our work in a few slides. Everything is done under supervision of Assistant Professor Marco Fleischmann. So our past research revolved around vegetative propagation and selection of mother plants of hemp varieties for CBD production. We studied 4 varieties with 30 genotypes per variety. We evaluate the mother plant branching using 3 different pruning techniques. Over a longer period of time, we evaluate the rooting ability of the root system, so basically how one genotype is useful for vegetative propagation by stem cuttings, and we did analysis of secondary metabolites. Based on collected data, we select the genotypes with desired traits and save it for later research. Now our attention is drawn to cannabis grafting. If you don't know what grafting is, this means conjunction of at least 2 different plant parts together to form a grafted plant. And we are studying how different rootstocks affects the science. So how different root system affects the upper part of the plant, so basically the whole plant. And we are studying the morphology, physiological parameters, and biochemical parameters of the plants. And right now, we are also working on breeding, or we are breeding new varieties. We are working on CBG genetics and CBD. The ultimate goal is to develop feminized seeds of industrial hemp, so for production in Slovenia. We are crossing for CBG, the foreign CBG genetics, to obtain new ones. With CBD, we are preliminary crossing the high CBD genotypes, selected genotypes, with selected industrial hemp genotypes. And the idea is, again, to get feminized seeds of industrial hemp. Thanks.
Let's move on, please. I think Bence has video to show.
Hello, Hello everyone, my name is Bence Mátyás. I'm the CEO and founder of the Genesis SFL. It's a Hungarian company, let's say startup. It's 4 years old innovation company. We are involved in both upstream and downstream space utilization, which means that our basic research was related to Mars. In order to, we were cooperating with the Jet Propulsion Laboratory of the NASA. If you know this department, they are responsible for the Mars rovers development and many other analytical technique in order to detect organics on the planet Mars. So that was an open call like 4 years ago, and we were at a Latin American station in the Cotopaxi volcano, suggesting to the Jet Propulsion Laboratory the most viable analytical tool which can be used for Mars research. So we made our own experiments in these volcanoes, and also other research groups were involved in this decision, but the choice was microchip electrophoresis-based instrumentations. So when we established our own, first that was a spin-off, and after we make another entity in Hungary, we use the same technology, which is coming from space, for this microchip electrophoresis. Microchip electrophoresis is a really big family, and basically it serves nowadays medical purpose. In human medicine, they use this for cancer and diabetes 2 early detection. Using mainly glycanic structures. They are free sugars, oligosaccharides groups, and we are using it to get information of the protein stress level before the visual symptoms appear. Why it's important for us? It's important also for the upstream and also for the downstream utilization. In the upstream, because of that, we can provide a proper health monitoring of the plants in space. Basically, for the people who are involved in pharma business, it's not new that most of the big discoveries happening in the International Space Station, especially in the Russian cabin, because the big pharma companies sometimes rent a place for research. The research involves like one month, basically. We also get an opportunity, thanks to the HUNOR, Hungarian Astronauts Program. We will launch our own equipments to the International Space Station for 2 purposes. One is for human medicine and other for plant utilization. So let me talk a little bit about the downstream space technology, because that's why we are here and that's why we received this kind of invitation and opportunity, is that we are developing different species-specific modules to detect early stress in plants. And in the previous 7 years, we were focusing on tomato, indoor application. After we went outdoor and we were measuring mainly maize and sunflower in over 600 hectares. We started in Hungary, and now we are expanding our partner programs in Slovenia as well. And since this year, we are new in this medical cannabis business. Our current project is make a single-run separation for 14 cannabinoids with a portable device. It's a microchip electrophoresis device, which I can compare mostly for HPLC, which you can use. It's a liquid separation-based technology, but we don't use any moving parts in the device. So that's why we can bring it outside without significant effort and calibration or recalibrations. This device must be calibrated after every 20,000 measurements, and also about many factors. So our main line is a glycanic research. It's basically an in-deep molecular analysis, and we receive information of the protein health. So we already started to build up our database for the macro and micro elements deficiency. So we can compare these changes in this glycanic structure compared to that. So the farmers or the grower not only receive information about what is the element composition or what is the element which was uptaken to the plants already, but also they will have some reference database, and it also serves as a decision support tool in terms of the leaf fertilization and other terms. Can be very useful. In the indoor applications, we are going back to the lab, because now we are testing, thanks to the nature research, Research Nature Institute of Slovenia, thanks to Božo. We receive opportunity to validate our technologies also with HPLC methodologies, which is more well-known in the analytical industry. So we are comparing our data sets with the HPLC results, and also this aim for this year is also get it to the national standards with this microchip electrophoresis technology. We have a kind of easy way in order to the validation, because this technology is coming from the capillary electrophoresis, and the capillary has a very well publications. I mean, in the literature is very well known, and most of the people aware about this. But the HPLC, which I think is in a wider range of this industry. So with the microchip electrophoresis, we're trying to get a bigger range of individuals who are using it because of its sustainable features. I'm talking about the less chemical usage. We are talking about microliters per samples when we are using. Also the other reagents which are involved in the sample preparation and the measurements are very low, and not talking about the energy usage. Like also if you can compare a big machine like HPLC on the table and compare to a portable device, it can be obvious that it has a really minimal energy and the chemical demand. We came up with a brand called GenoPlant. So at the moment we have 4 modules on the market for plant research, and now thanks to the cooperation we are continuing for soil measurements for the same technology. So we are very grateful for the opportunity to test our devices on this market, and we already made a great step already in this year, I think, because of we start this single around separation of these 14 cannabinoids. Also, we are trying to expand our portfolio in terms of methodology and serving real market needs. Thank you so much for the opportunity to be here. It's great. Thanks.
We'll move on with Clement and his company Plan Z.
All right, hello, my name is Clement, and I would like to present our new technology that we developed for cannabis plant cultivation. It's a stem infusion system. So when my brother and I started the company, we were very interested in how to increase yield in cannabis growth. So when we studied the state of the art, we came to conclusions that there are in the world, people can grow cannabis with crazy yields right now. And more or less it has plateaued. So what we realized was that the reason why cannabis cannot yield more is the 2 main factors. One, it can only do as much photosynthesis as it can, no matter how much light you put. That's one limitation. And the other limiting factor is that it can absorb only so many nutrients through the root system. So no matter how much you fertilize, it will only absorb so much. So these are the 2 main drivers that drive yield. So for this, we thought about what if we were able to deliver energy and nutrients directly into the plant stem to avoid the leaves, to bypass the root system. So this technology was done already on other agricultural crops, but we reimagined it and developed it specifically for cannabis cultivation. So it consists of 3 components. One is the infusion device itself that attaches directly to the plant stem. Then it's a pressure splitter, because you need to provide these nutrients into the plant under pressure. So we have a pressure splitter, so you can apply this to multiple plants at the same time. And then we developed our proprietary medium that contains water and only compounds that are naturally present in the plant stem. So we're not adding any chemicals to it. So how it works? Basically, after the plant has gone through the vegetative stage, so after the regime has been switched to flower, you attach the infusion system to the plant, and you leave it on until the end of the growth cycle, until the harvest. So there is nothing else you need to do. So the device then slowly injects nutrients over time through the under the pressurized system. Everything else stays the same, so the flowering regime stays the same, the fertilization regime stays the same. This is basically an add-on to the operation. And what we found was that we did two larger studies. One was with biotechnical faculty. Luca was actually part of that study. We are publishing a scientific paper towards the end of the year from this study. And we did another study with a professional grower who's also here today with us. You can talk to him directly also. Where we looked at how this technology impacts their regular growth line. So in both cases, we were able to show 25% increase in dry and wet flower biomass. And we just last week we analyzed also the cannabinoid content with HPLC, and we realized that also the amount of cannabinoids stays the same proportionally, so concentration of cannabinoids stays the same or is even slightly increased. So you get 25% more flour with the same or slightly higher cannabinoid concentration. So this can significantly boost the profitability and the production of cannabinoids and cannabis flowers. Additionally, we observed no adverse effects for the plants, so plants stayed healthy. They even looked a little bit better because they receive water as part of their infusion system, so they were less sensitive to watering cycles. So they stayed more upright throughout growth. Okay, so at this stage we are looking to expand this technology to more professional growers. So if this is an exciting technology for you, or you are looking for ways to increase your yield, please come and talk to us. We are both here. We are doing pilots now with a couple of organizations, so happy to do one with you as well.
Thank you, everybody, for these nice presentations. I think we still have time for some questions from me, which I prepared. I will start. Andrea, one of the main goals of your project I saw is on the presentation is to increase the yield and also the level of secondary metabolites in the plant. What are actually the main challenges you and your team is facing with your research group regarding CBD and THC strains?
Thank you. Yeah, the main thing is that cannabis plant is quite heterogeneous. So whenever you're doing crossings or feminization, you can expect different kinds of plants. But we have experiences from hop, as I mentioned as well. It's comparable in that way. All the other techniques can be used, as I mentioned, different markers which are available. So this is main thing which are we doing. What is our, let's say, more or less thing which I would like to expose is that when we will have a, let's say, new variety, it's still not the legislation so far in Slovenia that we could grow that plants under Slovenian conditions. Which is strange in a way, because from the ministry we just got the info, let's say some time ago, that in Slovenia in general we could produce just, let's say, a few grams, which is needed for Slovenian patients, which is ridiculous comparing to that, let's say if we make a comparison, we are the 5th producer of hops in the world, and we are exporting 98% of it. So why shouldn't we be the exporting country for cannabis flowers as well? So this is more or less the thing which I'm thinking as a breeder. We will have very good variety for our customer, but we could grow. Now they are preparing the places in the countries which are, let's say, a few steps forward regarding the legislation, like Germany, Czech Republic, and I hope that Slovenia will be there as soon as possible as well.
I think we will follow very soon. You also mentioned that you're trying to present, to make a product from the partner in the industry. and I will to launch it commercially. So how do you assure the standards and which cannabis products on the market requires, let's say, from the field to the final product on the shelf?
Yeah, we have for this outdoor growing, we have GACP already certified, then we have accredited lab, and we are in the process for getting GMP as well. So we are looking for different kind of standards which needs to be used to, and also we have ecological plants and so on. So we are quite well educated in getting different kind of certificates as well.
I think it's necessary. Luca, you showed us a little bit different approach that Andrea's team is using. The grafting of hemp is a very new method. I'm not sure if the growers know it yet or use it frequently. So could you explain us what are the advantages of grafting in hemp, and maybe what kind of benefits can we expect from these grafted plants?
Yeah, grafted plants can give us many advantages over the traditional cloning or by the stem cuttings. I will start with, it's normally that we have a genotype that is really perfect with cannabinoid profile and all the secondary metabolites, but it's nearly impossible to vegetatively propagate it. So it's a problem to get the roots of the cuttings. So with grafting, this is really eliminated, or we can really increase the propagation of selected genotypes. This is like the first thing I would say, but with selected rootstocks, so desired root system, we can increase the overall yield, overall vigor of the plant. The plants are more healthier, the stronger. Overall, like the yield of flowers or inflorescences of square meter is higher. But with desired or some rootstocks could influence the activity of secondary metabolism, which means that overall yield of secondary metabolites would be higher. Also. But yeah, if the higher secondary metabolism is present in the plant, means that from the start or even late in flower, the plant is more tolerant to pests and diseases. Okay. Like even with selected rootstocks, some rootstocks are totally resistant to to soil-borne diseases, and we can eliminate the problems with pathogens.
Great. You also mentioned that you are crossing high CBD genotypes with different industrial hemp genotype. What is the purpose of this crossing?
So we started from, all the plants right now are on the field, like the really good genetics of CBD are hot, how to say, like the federal limit is 0.3% of THC. Normally on the field, it's THC a little bit higher than 0.3. Our idea was, in the first place, to cross it with industrial hemp to reduce THC levels to 0.3.
That's a challenge, I guess.
Yeah, if you want to have a high CBD level, it's really, really a challenge.
Mm-hmm. What do you say? What do you mean when you say high? How much? So above 5-6%?
Yeah,
usually
we're talking
THC
about 10% at least of CBD.
Okay.
Yeah. And the other goal is, we saw it from the field that many farmers cut the plants down early in the end of the season because of bad weather conditions. Because normally really good genotypes of CBD mature late, and okay, now our idea is now to produce a faster flowering strain to obtain variety that could be harvested early in the autumn.
Okay, nice. Bence, we'll move now to you. So you're developing, as we saw, microfluidics, and you also mentioned that you are cooperating with European Space Agency. But tell us, how is your technology also applicable in the space? And since we have two breeders here on the panel, how can you transfer your methodology to the grower or breeder?
A question. We highlight in the video in this portable feature with the space research because it can be used in some remote places and in microgravity because of the capillaries. So all of the separation happens in capillaries, so we don't have to generate artificial gravity, or that's why the selection was, narrowed to the microchip electrophoresis development. So that's why the space research. It could be also possibly working with HPLC because it's also, liquid separation, but there's much more moving parts, and it's much more complicated to set it up in the International Space Station. So that's why the microchip electrophoresis. So about the plant specification, like how we can implement this knowledge, we can provide, or we are providing, a nice technological background. Like we are having a nice hardware, but how we are configuring this hardware, it's also another thing. But it's a really lucky scenario because we started as a research group on glyconics. So we know more or less about the separations, what a researcher is expecting, or in this case, what is the grower expecting. We are trying to, with this portable device, which we bring here today, or to this event, it's basically aimed to serve growers' needs or somebody who has their own laboratory or their own plantation, and they want to have measurements on the field without hiring some experts.
Okay. Maybe a second question from the analytical point of view, which I'm much closer to. So we know that cannabis plant has along THC, CBD, and CBG also present many minor cannabinoids, which occasionally present challenge to detect them or identify them. So my question would be about the sensitivity and accuracy of your device, and what are the actual benefits, as you already said, a few of them, for the user?
It's because if it's an analytical technique, like the accuracy can be comparable to HPLC or even a little bit, but it's hard to explain because as we are comparing pixels to theoretical plate numbers, but we are talking about exact matches on 4 decimal. As in HPLC case, and the peak area is also the repeated peak area. The differences of the repeated peak area determine the accuracy. So and the LOD, we are talking about in the cannabinoids, between 1.1 to 1.7, started with the CBD to the THC, microgram per milliliter. So it's like a 6 decimal error margin.
Enough,
and the matches are 4 decimals.
Okay, thank you. Clemen, your technology which you are developing is a steam infusion for the plants, which is in a way biostimulant. But as a grower, I would be very interested in the financial scheme when using your technology. We know that probably industrial growers usually have financiers and they have money, but what about home grower? Can they afford your technology?
So to calculate the return on investment of this technology, we used 2 examples. Like maybe the first example is using from the numbers a larger German grower of medical cannabis that has, let's say, more than 1,000 plants, selling, let's say, the final product at the German average gross price. We showed that the return on investment is 100%. So what this means is that for every euro that they put into the device and the medium and the technology, they get 2 euros back in the first growth cycle. So the return on investment is pretty rapid, as the 25% increase in yield is quite a lot. It's different for CBD. There, because of the price of the flower, it's the return is slower. For the home growers, so our device is completely modular, so you can use it from growing one plant to growing hundreds of thousands of plants. The devices stack, so basically connect. It's the same device, it's just connected to form large chains. For home growers, they are usually, so the calculation is actually using different numbers in the end is very similar, because they typically, if they are looking to sell, they sell for a larger price than what the German average gross price for large manufacturer is. Of course, for them, just having one system the price is also higher, but what we always say when we are developing this technology is that there should be one growth cycle that pays off for the investment. And yeah, so far for medical, we were able to.
So it's mentioned for everybody, even
Yeah.
for the single. But did you mention the price? What's the price of the?
Depending on the size, but typically, so for one cartridge that is used for one plant for one growth cycle is €20. That's if you just buy one. But then you also need to have the device, so the system, the pressurized system. This is a one-time investment that then lasts for many growth cycles.
Okay, thank you. So I think we are ready for the questions from the public,
Yeah,
if there
we
is
have
any.
time for maybe 1 or 2 questions because everybody is hungry. Or does anyone have a question? Hunger is outweighing your need for knowledge? All right, well, there it is then. Let's go eat. Let's hear it once again for our panel.
Thank you.
Dr. Stuckel and everyone else. Very informative. They're going to open that door right there in a minute, and we'll have lunch. We'll be back here at 1400 for more panels. Please go visit our exhibitors over there and donate to the Flood Relief Fund as well. And don't forget the party tonight. The first shuttle bus leaves at 8:45, and wear your badge. Wear your badge so you can come to the party tonight. All right. Enjoy lunch. We'll see you in about 90 minutes.